Hello everyone, welcome to yet another video on Calculus 1, and we're still focusing on the limit of a linear function. So our question today says, use the precise definition of a limit to prove that the limit as x approaches minus 1 of 7x plus 10 is equal to 3. So here is the proof. We copy the question. The limit as x approaches minus 1 of 7x plus 10 is equal to 3. If you substitute 1 minus 1 in the place of x and simplify the whole of this expression, it gives you 3. But the question requires us to use the precise definition of a limit to prove that this limit does exist and is equal to 3. So step number 1, we have to state the precise definition of a limit, which says if the limit as x approaches a of f of x is equal to L, it means for every epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus a is less than delta but greater than 0, then the absolute value of the function minus the limit must be less than epsilon. Next, we put our limit into the precise definition of a limit as follows. Therefore, the limit as x approaches minus 1 of 7x plus 10 is equal to 3 means for every epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus 1 is less than delta, the distance there between x and minus 1 is less than delta but greater than 0, then the absolute value of our function, which is 7x plus 10, minus the limit, which is 3, must be less than epsilon. Now let's simplify this part here. 2, 0 is less than the absolute value of x plus 1, and this is less than delta. Now we perform 4 steps in our proof. Step number 1 is to state what we're given. So in this case, we're given that epsilon is greater than 0 over here in our precise definition of a limit there. And step number 2 is the choice of our delta, which at this stage we do not know. As you would recall from in the previous video, it is step number 4 that helps us determine the choice of delta we need to make, so that if this is true, then that one follows. Right. Step number 3 is the assumption step. So we assume that this condition here holds. 0 is less than the absolute value of x plus 1. We assume that this is less than delta. We assume that this condition holds. In step number 4, we notice that this expression here can be simplified, which is 7x, absolute value 7x plus 10 minus 3 simplifies to the absolute value of 7x plus 7, because 10 minus 3 is 7. And factorizing the expression over here, 7x plus 7, we obtain the absolute value of 7, open brackets, x plus 1. Moving on to the next step, we obtain the following. That the absolute value of 7 is 7 times the absolute value of x plus 1. Now, if you notice in this step over here, if you notice there in the assumption step, we say the absolute value of x plus 1 is less than delta. That means if we take our delta, substitute here, we're going to obtain an expression that is 7 less than 7 delta. And we set 7 delta at this stage to be equal to epsilon, and determining the value of delta, we get delta as epsilon over 7. So this is the choice of our delta, which will, as you will see shortly, will make our condition achievable. In other words, we'll make the distance between the function and the limit to be less than epsilon. Now, if we take this, substitute in there, you get an expression that is exactly equal to 7 times epsilon over 7. And when you cancel these two, you get epsilon. This should be the end of the proof. But like we did in the first example, we can perform checking here to see that this indeed is the correct choice of delta. How do we do that? Well, checking requires us to go back to the assumption stage. The assumption stage says the absolute value of x plus 1 is less than delta but greater than 0. That means if we take this, substitute in that place, and manipulate this expression here, we should get that one there. In other words, if this is true, then that should automatically be true. So let us put our choice of delta in that place. So this is distance, remember, this is distance. And distance is always positive, so we can ignore the first part here. So we'll say this implies that x plus 1, absolute value of that, is less than, our choice of delta is epsilon over 7. Epsilon over 7. And if you multiply both sides by 7, you're going to get 7 times the absolute value of x plus 1, which is less than epsilon. The absolute value of 7 is 7, so we are allowed to say that this is the same as the absolute value of 7x plus 1 in brackets like so. And this is less than epsilon. Expanding this part here allows us to say that this is the same as absolute value of 7x plus 7, and this is less than epsilon. Notice that 7 can be written as 10 minus 3. Here, over here, 10 minus 3. So we can write 7 as 10 minus 3. And this is less than epsilon. If you notice, this is exactly what we wanted to achieve. We said if we can find a very small number delta, such that when we place in that position and manipulate this expression here, it should give us that. That is the essence of the precise definition of a limit, which says if you are within delta of our value of a in the open interval, you must be within epsilon of the limit on the vertical axis. So this marks the end of our video for today. If you are new to this channel, please subscribe, share these videos. It will go a long way in helping us grow this channel. See you next time.